And here is part 2 of the answer key video for the Unit 6 review worksheet. And it starts at number 9. I'm going to kind of go through these a little bit fast. And you'll notice that I will have some of them already shown the work done. But that's okay. I'll show you those, and we'll briefly go through those because I don't want to spend too much time on this whole thing, just so that you get the basic gist of the problems. Maybe you're struggling with some of them, and this will help. So, if you recall, part 2 was about the substitution method. So 9 and 10 are still using substitution. All right. So we use the substitution method. All right, and in so doing that, we are going to, so we're going to do some substitution for number 9, but if you notice, we don't have anything solved for x or y. So we need to solve one of the equations for x or y, and I'm going to look at that second equation because there's a y by itself there, so it might be easy to solve for. It's just one step, and we're going to subtract 4x from both sides to cancel that out, and you end up with y equals 8 minus 4x. And then we bring this down, we still have 5x plus 2y equals 7. Now, since one of them is solved for x already, that gives us something to work with. Since we know y is equal to 8 minus 4x, we can plug in 8 minus 4x for any y, since that's what y is equal to. If you notice, we have a y right there. So we're going to plug it in for that y. All right, and what it's going to look like then, I'll make this a little smaller so we can have more space to work. But what it's going to look like when you do that is it'll be, you still your, oops, I'll use blue there. Okay, since we're plugging this 8 minus 4x into this equation, we'll have the 5x still, plus 2, instead of times y, we are going to do 8 minus 4x. And so that's equal to y, we can replace it. Alright, and that's equal to 7. Alright, do some distributing here. We have 5x plus 2 times 8, which is 16. And minus, because we have a minus sign, 2 times 4x, which is 8 minus 8x, equals 7. And I'm going to combine some like terms. We have a minus 8x, and we have a positive 5x. That's negative 3x plus 16 equals 7. When we subtract 16 from both sides, you end up with negative 3x equals negative 9. And lastly, divide both sides by negative 3, and you end up with x equals positive 3. So that's half the battle there. We got the x value. That's the tough half. Now it's pretty simple to solve for x. You can use any one of these equations. Solve for y. And I'm going to actually use that equation that we solved over here for y. I'm going to plug in 3 for x right there. So it'll be y equals 8 minus 4 times 3. So y equals 8 minus 12, which means y equals negative 4. So our solution, I'll write it way up to the top left here. Our solution is 3 and negative 4. That's the solution to this problem. So it took a little bit more work to start it off to get one of them solved for y. And maybe you'd realize you might want to do a different method for one like this. But if I'm asking you to do the substitution method, you need to show me how to do that substitution method. And you first need to solve for one of the variables. Number 10 is very similar. only one step shorter, because if you look at the original, x was already solved for. So what I did was take whatever x is equal to, in this case it was 2y plus 11, plug it in for the x in the other equation. So it would be down here, 3, instead of 3 times x is 3 times 2y plus 11, and you still have your plus 9 equal to, or plus 2y equal to 9. Some distributing and combining of like terms, you end up with 8y plus 33 equals 9. And when you solve that using two steps, you should get y equals negative 3. Now what I did with that is plug that back into one of the equations. I did the top one. I thought that would be easier to solve for our x. And it would be x equals 2 times negative 3. We'll plug in negative 3 for y, plus 11. Multiply the 2 times the negative 3, you get negative 6 plus 11 is 5. So our x is 5, our y is negative 3, and that tells us our solution is 5, negative 3. So there's some more with the substitution method. Now on to the elimination method. The elimination method is great, and I'll show you a couple of reasons why. Mainly these first two problems right here. If you see something like this, you got to be able to use the elimination method, because it's going to make your life so much easier. So first of all, if our equations are lined up, oftentimes if they're in standard form is when we use elimination. But look at the variables. Make sure they're lined up. So we have x is lined up here, y is lined up there, and then on the other side of the equal sign we have our constants over there. But look at the coefficients of x. You can look at the coefficients of both variables, but the coefficients of x for these two equations are just opposites. And we know when you add opposites, they cancel each other out. 8x plus a negative 8x is just 0. So that cancels these out. And you're left with 3y plus y is 4y. And then negative 9 plus 29 is actually 20. It's just like 29 minus 9. And when we solve for y, 20 divided by 4 is 5. Look at that. I hardly showed any work, and I already got one of the variables. That's another reason why this substitution method, or this elimination method, is so great. Now what I'm going to do is I'm going to plug that back in for one or both of the equations. For this problem, I'll plug it in for both. So our first equation is 8x plus 3 times 5 instead of y equals negative 9. Second equation is negative 8 plus negative 8x plus y, or 5 in this case, equals 29. Alright, so we'll do this one first. This is 15, but I'm just going to subtract 15 right away because I know that's 15. Subtract 15, 8x equals negative 24. That's 24. Divide both sides by 8. X equals negative 3. Alright. Now we're going to do the same thing with the right one, only this time we'll subtract 5 from both sides. You end up with negative 8x equals 24. And when you divide both sides by negative 8, you get x equal to negative 3. You get the same answer both ways. That's a good sign. Then you can put that into your ordered pair. So the solution here is x is negative 3, y is 5. That's your solution. Now number 12 is similar. We're still going to do it, combine these equations, but this time, if you notice, 5 and 7, the x's are lined up, but the coefficients are different. The y's are lined up, but the coefficients are exactly the same. They're not opposites this time. So in order to cancel them out this time, we have to subtract the equations. And remember, when we subtract the equations, we subtract everything. So 4 minus 8 is negative 4. 6y minus 6y is 0. So let's cancel out. And then 5x minus 7x is negative 2x. Solve both for x by dividing both sides by negative 2. You end up getting x equals positive 2. Awesome. I'm just going to plug this in for the one equation this time. And we'll have 5 times 2 plus 6y equals 4. We know that 5 times 2 is 10, so I'm just going to subtract 10 from both sides right away. And you have 6y equal to negative 6. And when you divide both sides by 6, you get y to be equal to negative 1. So with that, our solution, I thought we did green here. For this one, our x is 2, our y is negative 1. And there we go. So that's the important part about the elimination, recognizing that. I do have some more challenging ones here to show you, though, as well. I'm going to cancel out number 14. Don't do number 14. But we'll look at number 13. Number 13, if you notice, the x's are lined up, the y's are lined up, the constants are lined up. But there's no variables that would cancel out if we added or subtracted the two equations. So what we need to do is change one of the equations to make it so that there's something that can cancel out. And what I'm going to do is I'm going to look at the coefficients. Now I look at this is 1y and this is 11y. So what I could do is I could multiply this top one by 11 to get 11y on top. But let's look at the x's to see if there's an easier way. This is 2x and 4x. I know that if you multiply 2 times 2, you get 4x. So let's do that. I think that would be easier. Whoops. I'm sorry. So I'm going to multiply this first equation by 2. I think 2 is a nice small number that we can multiply. Because remember, if I multiply one thing by 2, I have to multiply the rest of the equation by 2. It's just like distributing, making sure it's all in balance. So when I do that, I distribute the 2 to all 3 parts. And our new equation would be 4x plus 2y equals negative 18. So here's our new system right here. And I am going to combine those two things. But looks like the x's are the same coefficient, so we need to subtract. So we want to make them so that they'll cancel out. So let's subtract here, and we subtract all the parts. So when I do 9 minus negative 18, it actually becomes a plus 18. It's going to be 27. 9 minus 2, or 11y minus 2y is 9y. And 4x minus 4x is 0. So to solve for y here, just divide by 9, and our y is equal to 3. So if you notice there, we had to change one of the equations to make this easier for ourselves. But once we changed that one equation, we're multiplying everything by 2, the whole equation by 2, the elimination method worked really nicely for us here. So if y equals 3, I'm going to plug that 3 in for, we'll go right there. So we have 2x plus 3 equals negative 9. Subtract 3 from both sides. You end up with 2x equals negative 12. And when you divide both sides by 2, you get x equals negative 6. And that's great because now our solution would be negative 6, 3. And we are happy because we have a solution. All right, that's one of the more challenging elimination problems that you'll have. I do have one more that I want to go through, one more elimination problem, and this is even more challenging. You'll see these on rare occasions, and there's other ways you can go about doing it. But let's do number 15. So if you notice, if you remember, we wanted to make sure that all the x's were lined up, the y's were lined up, and the constants were lined up. Right now, they are not. So let's just get the x's and the y's on the same side for this bottom equation. So I'm going to subtract 12x from both sides. So really what it's going to look like is this one would be, instead of this, we're going to write it minus 12x from both sides. It'll be negative 12x to make this more legible here. Negative 12x minus, or sorry, plus 20y equals 24. All right. And we have our negative 3x plus 5 y equals 6. All right, we got to change one of these equations or both of those to make sure that they are going to be something can cancel out. So it looks like negative 3 to negative 12. We'll multiply that by 4. How about? When we multiply all the parts by 4, you end up with our new equation of negative 12x plus 20y equals 24. Uh-oh. You don't have to go any farther. If you look at these two equations, they're exactly the same. Two equations that are exactly the same. That means that they're going to graph. If you show the graph here, when you graph them, one's going to be like this. I mean, it might not exactly be like that. The other one's going to be right on top of it. So that means there are infinite solutions. So infinite many solutions. And you don't have to go any farther. That's all I'm looking for. So if you see that, that's great. Because this hard problem turned out to be pretty simple when we notice that there's infinite many solutions. Alrighty. We're going to skip number 16 for right now, and we're going to do one of these word problems. Let's see. Number 7. Let's do number 17. I think number 17. Let's set them both up, and then you can decide which ones you want to solve. So it says Mr. Alvarado bought a total of 20 pounds of grass seed at the nursery for $168. He paid $9 per pound for Kentucky bluegrass and $6 per pound for tall fescue. Use a systems of equations to find how many pounds of each type of grass seed he bought. Declare your variables. So the first thing, make sure you know what variables you're talking about. So it helps to read this through a couple times, but it looks to me like we don't know how much Kentucky bluegrass, and how much tall fescue he bought. So we'll do, let's use X would be Kentucky bluegrass. And Y would be tall fescue. He's about 20 pounds. So total X and Y added together would be 20 pounds. We can say that's an equation right away. X plus Y equals 20. That's 20 pounds. Paid a total of $168, $9 per pound for X and $6 per pound for Y. So that would be, let's see, 9X plus 6Y equals, see, now we're dealing with money, so that's why I made the second equation about money, equals 168. All right, there's your system. You can decide. I would probably use elimination or substitution for this one, and it's up to you to solve. We'll set up the second one then real quick, and then we'll be done with this video. So the second one says you pay $24.50 for 10 gallons of gas and 1 quart of oil at a gas station. Your friend pays $22 for 8 gallons of the same gas and 2 quarts of the same oil. Use a system of equations to find the cost of 1 gallon of gas and 1 quart of oil. Declare variables. So it looks like right there, it already tells us what we don't know. We don't know what a gallon of gas costs, and we don't know what a quart of oil costs. So we can use whatever we can use x. We'll use x and y again. Keep it consistent. We don't know those things, so you can declare those variables right away. Let's look at the first sentence. It says you pay a total of $24.50. So I'm going to say something equals $24.50, I think, for 10 gallons of gas. Sounds like 10x to me. And plus 1 quart of oil. So 1y, or just y. There's one equation. Nice. Second one, your friend pays $22. So this is 22 for 8 gallons of gas, 8x, and 2 quarts of the same oil, 2y. Well, guess what? You've got yourself a system of equations right here. You get your 2 equations. You can solve it. Again, I would probably use elimination for this one. All right, so that's as far as I'm going to go for this answer key video. I hope it helps. You can also see part 1 of the answer key video for the review worksheet that I have posted earlier. So I hope it helps and enjoy it.